Hi, this is Robert Quimby, and I'm going to tell you about the Structured Query Language, or SQL, or as many people who are not me pronounce it, SQL, and how you can use this language to get information from databases. So in this tutorial, we're going to talk a little bit about what databases are and why you might care about them. We're going to learn how you can retrieve records from databases using the Structured Query Language, SQL. And we're going to have some examples. We're actually going to run some queries on a test database and see how that works. And at the very end, we're going to talk about ADQL, which is a version of SQL with some added functions that are very useful for astronomers. So that's the A in ADQL is astronomer. All right, so first let's talk a little bit about databases and how they work. The basic idea here is that there is data that's going to be stored on some device in some manner. And you may be some end user and you don't really want to have to worry about how that data is stored. Like, do they have different pieces of information in different files? What are the names of those files? What directories are they located in? Is it just all in one big file? Like, you don't want to have to worry about that often when you're this end user. So we have this abstraction called a database. And a database is not just these three concentric little circle things here. No, this is actually some way of storing information on your computer and retrieving it. So the way things typically work is typically you have a client. This is your computer, and that client sends a command to a server which is connected to this database, and that database could be on that server. So the server could be a computer, and that computer could have some hard disks on it and have information stored on those hard disks in a certain way. And so your client could talk to that other computer and ask it to send you back certain records from this database. And by the way, this server could actually be running on your computer as well. But this is kind of the traditional way that things work. So where SQL comes in is this is how you are going to be asking the server to retrieve that information. So its job is to figure out how to store information, and its job is also to figure out how to retrieve that information in the most efficient way it can. So this is why databases are so powerful, because you can have a tremendous amount of data stored somewhere on a computer, and you can retrieve maybe just one record or 10 records or 100, whatever you want, in a very efficient way. And you as this end user don't have to worry about how to set that up so that happens. The database is what makes that operation efficient. That's the job of the database. So structured query language is this kind of bridge here. So instead of knowing the inner workings of the database, there's this simple abstract language that allows you to retrieve these records. All right, so this is SQL. And there's a lot of information out there on the web about SQL. There's some good tutorials here on this w3schools.com page. So you can go here, and you should, and learn about how this language is set up. There's all these different kind of commands you can do. We're going to focus in our tutorial on this one command here, select. There's other things if you actually want to create a database. You might care about some of these other commands, updating records, deleting records, creating tables and whatnot. But we're going to assume that someone has already done the hard work of setting up that database, and it's just you, the end user, who is now just trying to retrieve information. So to do this, we just need really this one command, select. And select has certain options that you can add to tell the database what you want. So the way it works is you type select, and then you have a comma-separated list of what values you want to retrieve from the database. And these data may be stored in different tables. So the data can be grouped together in what's called a table. And you can think of a table very much like a table that you've seen in a publication, or just has data organized into rows, and it has columns. And those columns can be these values that you retrieve. So you can select some set of columns, for example, from some table, and then you can put conditions on it. You can say, well, I don't want everything, I just want some of them, so I'll just limit to where some condition is true. So maybe you have a list of records of people, and one of the columns in each one of those tables is the name of the person, and another column is the age of that person. And you could say, just give me the records of people who are over the age of 18 or something like that. So you can have a where clause for that. You might want to order your output. You can have the database do it for you. They can be very efficient in how they order things, so it's good to use this option if you care about ordered output. So maybe order alphabetically by the names of the users or their ages or whatever. And then you can limit how many records you retrieve. So maybe there's thousands of records and you just want some sample. You want the top 10 or whatever. So you can say just limit to 10. So we're going to go over some of these commands in a little bit more detail and do some actual practical examples to show you how you might use that. To do this, we're not going to set up a server. This takes a bit of work to do, and for the simple tutorial, we're not going to do that. We're going to use something different that doesn't require this server at all, but it still uses SQL. We're going to use what's called SQLite. SQLite, as the name implies, is a very lightweight version of SQL, and it has a very simple setup where you just have your computer running some program, and it connects to a database, which is actually just a file on your computer. So there's no actual second computer that has a server running a program or anything. It's just everything is done by this simple application talking to one file and just retrieving information from that one file. So it's a very, very handy system, and this is actually the most widely used database system in the world. It's on your phone. It's everywhere. So this is a handy thing to know. So there is a Python package called SQLite 3, and this will allow you to what's called connect to a database. So we can actually connect to a database and then retrieve information from it. So there's a database that has already been created for you. It is in your media folder, and it is called example.db. Very clever name there, example database. So we can connect to that database, and then we'll have this object here that we can use to query the database and retrieve information. When we actually do those queries, it's very handy to use this other package called pandas. Pandas is part of SciPy, and it is kind of the go-to package for people doing data science in Python. So what we're doing here is actually something that's a data science topic. We're getting data from a database. So we're going to use pandas just because it's very convenient. We're not going to actually use much from pandas. We're just going to use really one function called read table, which will allow us to execute this query and then look at the results and download the results. So we're going to import pandas as PD. So everywhere you see PD, that's this package pandas. All right, so the first thing you need to do if you want to retrieve some information from a database is you need to know what information is in the database. And so I've created two tables in this database. One of these is called stars, and this database holds information from the Yale Bright Star Catalog. This is a catalog of the brightest stars in the night sky. It's got 9,000 of these. So in this one table, there are 6 different fields, 6 different columns if you'd like. There's a field that has the identification number for each star. It's a unique ID for each star, a name for each star, not for each of them, for most of them. Actually, not even most of them, for some of them. It has the right ascension and declination, just expressed in decimal degrees, and it has the V-band magnitude, and it also has the spectral type. This is a string which tells you the class of the spectral classification of the star, the OBAFGKM type, and the luminosity class as well. We'll see that. So this is one table, and we have all that information for 9,000 different stars. And then there's a second table called spec class, and this is a completely different set of information, although it is somewhat related, as you'll see. And in this table, there's 4 different columns. One of these gives the spectral classification. So this is your OBAFGKM. And then there's the luminosity class. This tells you, is this a main sequence star, or is it a giant or a supergiant? And we have a very, very simplified version of this. This is a very simplified table. It doesn't have all the different luminosity classes. It just has these 3 categories here. It also gives the typical temperature for a star that has a given spectral class and a given luminosity class. and the absolute magnitude typical for a star of a given spectral class and a given luminosity class. So we'll see these data in a second, but you can see that this is just telling us kind of generic information about what a star's properties are if it belongs to a certain spectral class. All right, so let's run a select statement. So we're going to actually pull some data from this database that we've already connected to. So we already have this connection here. We're going to use pandas, and we're going to use this read SQL query. So all we have to do now is we have to supply it with a query. So we're going to select some information from the stars table. So what we do is, in quotes, we type select, and I'm going to write the keyword, the commands that are SQL commands in capitals, all caps, but you don't have to. It is case insensitive language, so it doesn't really matter. It's just kind of a traditional way, so it makes the queries look a little more clear. So we want to select everything from this table. So we're going to say select star. So that's going to give us all the columns from stars. And that's it. Select all the columns from the table stars. And we can run this, and here's what we get. So this is the output from our query. We're looking at what's technically a pandas data frame, but we can really think about this being very similar to a NumPy structured array. So this first column here, this is just the pandas row number, so that's from pandas, and these are telling us the column names that we have. But then all the data in here, these are the data that we just retrieved from our database. So we have, you can see some IDs for some stars, we have names of some stars, not all of them, then we have right ascensions, declinations, Vmags, and spectral types. Okay? So maybe we didn't want all this information, maybe we just wanted a couple of those columns. We can do this. We can write a slightly different query. We can just tell it what columns we want from stars. So maybe we just want the RA and the dec columns, like that. So we can run this, and then you can see we'll just get those two columns in the output. So this is convenient. Sometimes you want to do this because maybe there's a lot of data in that table and you don't want all the different columns. You just want two columns. So this is a faster way, more efficient way of doing it. So we looked at one of our tables. We have another table called spec class. Let's take a look what's in there. So we'll run this query, and we can see, again, we have our different rows that we've retrieved, and we have these columns: spec class, lum class, temperature, and absolute magnitude. And so you can get an idea of what's in this table here. There's 97 rows. A few of them are hidden here. Okay. So maybe you didn't want to retrieve all these rows. So we saw a way where we can just retrieve one or two columns, but if only we're interested in O stars or only interested in A stars, we could write a query that only returns the specific rows we're interested in using this where statement. So now we're going to go back to our stars table, and we're going to retrieve everything again, but let's put a condition on here. So instead of just pulling over everything, let's just pull over the brightest stars. So let's get the stars where the Vmag is greater than, less than first magnitude. So if we run this query, there we have it. There are 15 stars in the sky which are brighter than first magnitude to an observer. So these have some famous examples like Alpha Lyra. There's Vega, close to 0 magnitude. We have Alpha and Beta Orionis, I should say. That's Betelgeuse here, and this is Rigel in the constellation Orion. So we just have these stars, and if we wanted, we could change this condition to something else if we wanted to select a different bunch of stars. One thing we can do is actually we can do multiple conditions, and we can put those together with and there's also an or if you want to use that. So we can select, for example, just the right ascensions and declinations from the stars table where the V magnitude is less than 2.5 and the RA is greater than 65 and the RA is less than 95 and the dec is between -10 and 10. So we can run this query and we can retrieve these stars, and now I'm just saving the output into a variable so we can do something with it. So up till now I've just been printing it out so we could see what it looks like. But let's do something with these data. So these are stored now in in an object that, again, it's a data frame in pandas, but it's very similar to a structured array. At least we can use it similar to a structured array. So what we can do is we can take the RA column and the dec column, and we can plot that as red circles and see what we get. And this is what we get. And this might be a familiar shape to you. There's 3 stars like here, one up here, one up here. That's Orion's belt. So we did a query that selected just the brightest stars in Orion. We could do a similar select with our other table, the spec class. We can select everything where the luminosity class is either 5, 3, or 1 for our main sequence stars, our giants, or our supergiants. Remember, this is a very simplified luminosity class. Normally, supergiants are divided into 1A and 1Bs, but we're just lumping them all together because that's all we have in this very simplified table. So we can run this. So you'll notice how I'm doing this. I'm just defining this query string, and then here I'm actually formatting the query with the value that I care about, and it's just putting those in here. So I can run this, and that'll do actually 3 queries here. So now we have 3 different outputs, and then we can plot these, and we'll plot temperature versus absolute magnitude for main sequence giants and supergiants with different colors, and that's what this looks like. And this might look familiar to you. This is, of course, an HR diagram. Here's the main sequence, here's the giants, and here's the supergiants. We can do more queries. One thing we can do is that we actually use the database to do some calculations for us. If we wanted to say what is 3 plus 4, we can actually select that, and it'll tell us that 3 plus 4 is 7. All right. Now, often when you do this, you actually want to give a name to your output. You don't want to say, give me 3 plus 4. You want to say, give me the sum. So we can define what we want this output to be. So we can use the as command and call it sum. And this will name our output sum, as you can see here. So now we can reference this column by the word sum. You can do more than just simple calculations. You can actually take data from a table and do operations on it, and you can actually even do that in the where clause. So one thing you can do is you can take maybe those right ascensions from the stars table, and you can divide those by 15. Or actually, why don't we multiply? No, we're going to divide these by 15. I was right. Because the RA in the table of stars is in degrees. If I divide by 15, I'll get it in hours. So let's store this as HRS for, actually we'll do it HRA for hours and RA from stars, and we can run that query. And here are the decimal hours for all the stars in the table. Maybe we didn't want all these. Maybe we want them ordered differently. So let's first limit how many we get. We can just say limit just to get 10 of the top 10 outputs. And maybe it looks like it's starting. So I should say, when you retrieve data, if you don't specify how you want it to order, the database is going to order it however it thinks is most convenient for it. That may not be the most convenient way for you. So if there's a way you want it to be ordered, you can use the order by command, and you can say order by HRA, for example, and maybe you want these to be descending, so use DESC. And if you run that, it'll give you the biggest number first and descending values in that order. All right, so these are kind of simple ways to query a table. It may not seem very useful for you at this point. Here's where it gets really useful. You can actually join tables. So we have 2 tables here, and they have different information in it, but there is a connection between these 2. And we can actually exploit this and take data that's in one table and apply it to data from another table. So let's do this. Let's select from both our stars table and the spec class table, and we're going to take the name, RAN, DEC, and VMAG. Those are all in stars. And we're going to take temperature and ABSMAG from spec class. Okay? So how do we do this? Well, we have to do what's called a join. And we can do this implicitly just by using the columns in stars, using a column in stars that matches something in spec class. And what we have is in stars, we have a column called SPType. This is the spectral type. And we can set that, require that that spectral type is the same in stars as it is in spec class. Now in spec class, this is actually divided into two different columns. One of those columns is called SP class. That's the "Oh, be a fine girl, kiss me" part. And then there's another part, which is the loom class. So I typed these two vertical pipes here. That is the SQL version of adding two strings together. So this represents a column which is a string value, and this is a column which is a string value. If you do pipe here, it's going to take that column and add them together, like row by row. So we're going to say wherever the row, we're only going to retrieve values where the row in stars equals the row SP class in spec class plus loom class added together. And if we run this, here's what we get. So we have now the RA's index of stars and their V-band magnitudes. This is what we had in stars already. And now we have some estimate of what the temperature of that star is just by matching up the spectral types. And for the astronomers, we got to make sure we understand that this is just an approximation. Of course, we're not doing the detailed calculation of the spectral class. This is just this very simple spectral type that we're using. So these aren't exact numbers, but this will give you an idea of what the temperature and absolute magnitude of the star is for all those bright stars that have spectral classifications, matching our simple classes. All right, so we can do a step further here. If you recall, there's a relationship between the observed magnitude, the absolute magnitude, and the distance to a star. So we can actually now take that observed magnitude and absolute magnitude that we just got from this query here, these two things, and we can use that to calculate the distance to each one of these stars. So we can figure out the distance to all of these bright stars in the night sky. And by the way, if you don't remember where this 5 or this 5 comes from, you can derive this, and you should. Make sure you understand how this equation works. So we're going to apply this equation. That's our goal. To do this, we have to take 10 to some power. And it turns out that SQLite does not have a power function, so we can't do this as is. But we can add a function to do that. So I'll show you how this works. All right, so if we have numpy and we want to raise a number to some power, we just use the power function. So we can take a 10 and raise it to the second power, and that'll give us 100. So what we want to do is we're going to take our connection to our database, and we're going to use this function called create function, and we're going to tell it we're going to create a function called power. It's going to take two arguments, right? The number and the power that we want to raise it to. And then we have to tell it a definition for that, and this is already defined by numpy.power. So that's it. So we run this, and now we have in our database, we have this function called power that we can now use. And I should mention that in the full-featured SQL, there is a built-in power function that does exactly this. It's just not in SQLite. So let's use that now. So we're going to select now the RA index and the Vmag and the absolute magnitude, and we're going to use our power function. All right? And the first argument is going to be that number 10. The second argument is going to be the power we want to raise it to, which is whatever the Vmag is, and whatever that absolute magnitude is. And we're getting this from two different tables, remember. Added 5 and divided by 5. And we're going to give this a name. So we're going to give this whole thing a name. We're going to call it dist. All right, we're going to select that just like before from stars and spec class, where the spectral types are the same. And we're just going to get the top 10 here just to give a flavor of what we got. And this is the top 10 closest here. So here we have Alpha Centauri. That's the closest star system to the Sun. It's not quite 1 parsec, but it's pretty close to 1 parsec. A little bit pretty close to that. Again, we're just using this kind of luminosity class approximation, so it's not perfect, but these are some of the closest stars to the sun. All right, so we've been using SQL thus far, and SQL is great for databases in general, but astronomers have specific needs, and because of that, there is another language which is based on SQL called Astronomical Data Query Language, ADQL. Now, I guess if SQL is pronounced SQL, then ADQL should be pronounced ADQL, but I don't know about that, so I'm just going to call this ADQL. So this is a way that you can query a database and do things that astronomers want to do that are a little bit more difficult to do, possible to do with regular SQL, but easier to do with this kind of higher level ADQL language. So first I want to point out that there are databases out there where you can just type in queries and retrieve information, and they'll run on ADQL. So the most important one of these of late is called Gaia, and Gaia has this nice interface online, so we can click on this and go there, and this will bring up the interface, and there's different ways that we can search for things that are in the Gaia database. So remember, Gaia has this database holding over 1 billion stars, and it has all kinds of information about each one of those stars. And so we can do a simple query, but we're advanced people, so let's do this advanced query here. And so we can type in now a command that looks very much like SQL, and it'll look through its database and retrieve information for us. The key things, again, once you're starting out with a new database, you have to know what is in the database, what kind of information. So this is telling you what's in the database here. We can look at Gaia Data Release 2, and we can look here. This is the main table in the Gaia Data Release 2. It's called GaiaDR2.Gaia_source, and in this table, we have all these different columns, all these different fields that we can query for. So it gives all this different information from RA index to magnitudes and parallax and all kinds of good information in here. So there's some examples of queries that we can run on the Gaia database. I'll just pull up one of these. So let's just do this one here. This is a cone search, a very convenient thing to do. So we'll click on that, and now what we can see is we're going to select the distance as dist from this Gaia DR2 Gaia source table. This is the name of the table, where the point happens to be in some area in the sky, some circle in the sky. So this is the RA and the declination at the center of the circle. This is the radius in degrees of the circle. We're going to put that circle on the celestial sphere, and if the RA index from this Gaia source table is inside this circle, we're going to select it. So you can run that query, and it'll pull up the results here and show it for you. But what I'm showing you now is you can actually do queries like this directly in Python. So let's do that. There's actually, by the way, a lot of good documentation here for if you want to get started on these queries. They'll show you some examples. So first thing we need to do is we need to get this Gaia package from astroquery.gaia. So we're going to load that, and it will print this up here telling us that we've connected, and now we can actually execute queries. All right, so we're going to write up a query here. Again, this looks very similar to SQL because it's based on it. So we're going to select the RA index from the Gaia DR2 Gaia source table, and we're going to make sure that we have only records that have an RA index that are near RA index of 0, and we're going to do everything that's within 1/4 of a degree of that. So this is actually kind of a tricky query to do in regular SQL. You can do it, but it's a little bit tricky because if you remember the way our coordinate system works, it's a spherical coordinate system. So we're going to select values that are close to this point 0, 0 in the sky, which means we're going to have some right ascensions which are 365 point something, and we're going to have some that are 0 point something, but we're not going to have anything in between those numbers. We're not going to have any like 180s or anything. So it's possible to organize a query like that, but this is much more convenient to do it this way. So just say we're going to put a circle in the sky, we're going to find and look for points that are inside that circle, and And you can do a query and make sure we only pick bright stars. That's what I did here. So let's just pick the stars that have a B magnitude that's brighter than 15. So what we do is we use our Gaia object. We're going to launch a query. So we pass it this query, and we're going to store that as our job. And we do that, and this takes a little bit of time. Not too much in this case. There's all these error messages talking about this AstroPy VO table.tree issue. Don't worry about that. It's not our problem. So we got our job that's been queried. Now we can see what the results are. So we used job.getResults, and then we'll see what we just pulled over from Gaia. So here it is. We have RAs and decks of stars that are within 1/4 of a degree from right ascension deck 0, 0. And you can see, in fact, we got things that are close to 360, a little bit less than 360, and things that are a little bit bigger than 0. So, and it gave it to us in whatever order it wanted. So there you have it. That is a very quick introduction to SQL. We focused here on just how you can select data from a database. There's of course ways to create databases using SQL commands. That's a little bit beyond the scope of this particular tutorial. In fact, you can take a whole high-level engineering course on that if you're really interested. But for now, you got some pretty powerful tools now, so you can start exploring different databases out there and enjoy.